Hello everyone, this is How I Love Geometry. I'm Mr. Cao. This problem is 2019 Aime 1, problem number 3. PQR is a triangle and the length of three sides PR is 15, QR is 20, PQ is 25, and AB is on the side PQ, CD on the side QR, EF on the PR, and PF congruent to PA, congruent to QB, congruent to QC, congruent to RD, congruent to RE, all of the length of this 6 segments are 5, all of them is 5. So the problem let us to find the area of hexagon A, B, C, D, E, F, A, right? This is a 6-sided polygon, hexagon. So this problem is really not hard because we can easily to find the idea. We first, because we have 3 sides of this large triangle PQR, we can find the area of the triangle. And if we can find the area of 3 small triangles, we can use the whole minus the part, and the left will be the area of the hexagon ABCDEF. So if we are familiar with the number 15, 20, and 25, we will easily to find the ratio of between these 3 sides is 3 to 4 to 5, right? 3 times 5 is 15, 3 times 4 is 20, 3 times 5 is 25. So we know that Pythagorean theorem, it says if the right triangle, we will get the relationship between 3 sides is a squared plus b squared equals c squared. Now, we know the 3 sides is a squared. This is from right triangle we can get this relationship. And now we know a squared plus b squared equals c squared. I mean 15 squared plus 20 squared equals 25 squared. Now, if we got this relationship, we will get the right, this triangle will be a right triangle. This is also the Pythagorean theorem. So we know this is a right angle. If we got a right angle, it will make easier to calculate the area of this right triangle PQR. So we know PQR equals 1/2 times 15 times 20. So equals 1/2 times 20 is 10, so it's 150. That's the total area of this large triangle. And now we just need to calculate the 3 small triangles area and the PAF. So after we calculate these 3 small triangles area, I will review something about how to calculate the triangles area. So this triangle, we know the size for this PF and PA, all of them are 5. And how to calculate the area of this small triangle? there is the formula is like 1/2 a b sine c. It means this side, if we view it as a and this is b, this angle will be c. So for this problem, this small triangle, it will be 1/2 times 5 times 5. Now sine p, here is sine p. Sine p, according to the trigonometric definition of sine alpha, so equals to opposite side over hypotenuse, right? So it's 20 over 25. That's QR over QP. So we will get 5 is 25. So 1/2 times 20 is 10. This area is 10. And the same thing for the QBC is 1/2 times 5 times 5. Now here we will times sine Q, and it's 1/2 times 25 times angle Q, opposite side is 15, hypotenuse is 25. So this, the area is 15 over 2. 15 over 2. The area of this triangle RDE. This is also a right triangle. So the area for this small right triangle equals 1/2 times 5 times 5. So it's 25 over 2. Now we will get the sum of these small triangles. This one. So put them together, it will be 10 plus 15 over 2 and 25 over 2. So it's how much is 30, right? 40, 20 is 30. So the area we want to calculate, A, B, C, D, E, F, this polygon equals this 115 minus 30. So the answer, final answer is 120. To solve this problem is not hard. And here I just wanted to review something about the right triangle triple. It means if the three sides of a triangle satisfy the relationship, or the ratio is 3, 4, 5 and 5 to 12 to 13 and 7 to 24 to 25, 8, 15 to 17. That's used very, very frequently. That's for the right triangle, three sides, right? We know 3 square plus 4 square equals 5 square. 5 square plus 12 square equals 13 square. Yeah, it's the same thing, 7 square. And not just 3, 4, 5. Sometimes you will see maybe 6, 8, and 10, right? If this times 3, it will 9, 12, 15. And here, this problem is times 5, it will be 15, 20, 25. And sometimes you will see 5, 12, 13, or 10, 24, 26, 7, 24, 25, 8, 15, 17. That if you want to take part in the competition, math competition for AMC10, AMC12, and Aime, you should be familiar with these numbers. And now I want to review how to calculate the area of a triangle. So the first ways, right, to get area of triangle. So first one we know 1/2 times base times height. So everyone knows that, right? Second way is I just show you 1/2 AB sine C. Of course, it can be maybe 1/2 BC sine A and 1/2 AC sine B, right? No problem. And third one is Heron's formula. So it says like A equals the area equals square root of S and S minus A times S minus B times S minus C, then the square root. So if you're not so familiar with this one, you can search and learn by yourself. Okay, sometimes we can use the fourth way is we call them Pick's law. If you have taken the test of AMC8, maybe you know what I'm talking. Normally it's on a grade plan. I mean, like this way. There is a lot of grades, right? And maybe here is a polygon, this is a point, a vertex, we can call it vertex, and this vertex, and you will get this, yeah, and sometimes maybe this point, this point, and this point. So you will connect all of them, and it will, this Pick's law just to calculate the area of this polygon. So you just need to count how many points on the intersection point and how many points on the boundary, how many these points inside the polygon. Yeah, that's Pick's law talking about. So if you're not familiar, you should review this one, this way. The fifth way we call shoelace theorem, right? And it's like this way. That's absolute value sign. 1/2 about inside is the point's coordinate. So it will be like x1, y1, x2, y2, x3, y3, like this. So it's not just for to calculate the area of the triangle. It can calculate any convex polygon area. So we can use this way, use x1. You just in one orientation. So you can count clockwise or clockwise to write in the order to write the coordinate of the vertex. So the coordinate of this, you just use x1 times y2 and x2 times y3, then the last one will times this y1, and the sum of all of this minus y1 times 2 plus y2 times 3, and then the last one times this one. You got the sum of this, then got the difference of these two, right? Then times 1/2. Finally, you got the absolute value. That's the area of the polygon. This we call them shoelace theorem. If you're not familiar, also you can check on website or you can take the textbook to find this one. Next way, sometimes we can use this way. If we know here is an inscribed circle of a triangle, so this is radius, right? Radius, inscribed circle radius R, and if we know this side is ABC, so the area of this triangle, it will like, if we connect this one, that these angles bisector. This also the angles bisector. Yeah, I don't want to waste time to talk more about this one. I just want to get area will be 1/2 of the A plus B plus C. That's 1/2 of the circumference, then times R, right? Yes. That's one way to, another way to calculate the area of triangle. And also we have another way to calculate the triangle's area. So we call them, when we got, that's the seventh way. This is a circumscribed circle of a triangle. If the radius of this circumscribed circle is R, and how to get the area of this triangle? You say if this side is A, this side is B, this side is C. The formula is the area equals ABC over 4R. How we got this formula? Because we know the area is 1/2 AB sine C, right? And we know sine law. We got A over sine A equals B over sine B equals C over sine C, and equals 2R, and this R is the circumscribed circle of a triangle. So we can use this plugin this one. I mean, we use sine C, right? Here, if we from this one got sine C, C over 2R equals sine C, right? So we will got A equals 1/2 AB times sine C. Now this is sine C. C over 2R. We will got ABC over 4R. That's the formula of this way to calculate the area of this triangle ABC. These 7 ways I just review as normally we just use these 7 ways. Maybe I know maybe we will another different ways, but is not so frequently used. Okay, so today I just this problem is not hard. I just really wanted to review the right triangle, triple, and the different ways to calculate the area of a triangle. Okay, that's the point to stop. Thank you. Hope you enjoyed, and I hope it may helpful for you.